This topic alone has 2 weeks. So again, just listen. We'll get into much deeper things later on. But a process has one thread of control, but there can be multiple threads that basically help solve the problem a little faster. And where is it? You can work on different parts of the problem as well, maybe access different resources in the overall system to make it, well, finally get done faster. So there's a difference between threads and processes, so we have to be very careful about that. All the threads within the process share the same address space. There's where we have to be careful about. File descriptors, stacks, and other previously related attributes as well. So let's think of it as its own program running, but it's trying to finish one single process in the whole thing. Again, I'll explain in much more detail here in a couple of weeks. A thread executes its own stack. And it's a stack that you're thinking about, like call stack and what things need to get done. It's going to operate its own. It's going to have its own housing. So as you know, the more threads that you have, that means the more resources and taking up. That resources also is your CPU. And that's a parallelism. The more you take up the CPU with different threads or even processes, it's going to slow some other things down. But we're trying to use that to our advantage. Like processes, threads are identified by IDs, which I think I already talked about. There are some that it can be a local process. We'll talk about that. Again, this is an introduction. We'll cover much more here. Just remember the difference between a process and a thread in our basic terms for right now. That's all I'm after.